Alright, so for example 9, the last example in section 7.1, we've got three forces. You see them in your diagram, and they're all in equilibrium. Now the key for us, when forces are in equilibrium, they are going to form a closed triangle. Okay, so that's really going to be helpful to us in a second. So the angle between force 1 and force 2 is 100 degrees. So I'll just show force 1 and force 2 here in the two colors and the 100-degree angle that lies between them. We have, in fact, the magnitude of force 1, which is 12.2, and the magnitude of force 2. So I'll just write that in here on the diagram to help us out. So we need to find what is the magnitude of force 3. Well, again, we're going to come back to this equilibrium part, okay? Without the equilibrium, I don't even know if this question is doable. If it is, it's quite difficult. The fact that it tells us they're in equilibrium, now that relieves a lot of the pressure. So we have this blue vector, okay, force 2, and I'm just going to recreate that below here. So there's my force 2, and its magnitude is 10.7. We have force 1, and I'm going to recreate that here. Force 1 magnitude is 12.2. And last but not least, we have this force 3, and we need to know its magnitude. Okay, so this diagram you can see in front of you. If we can figure out a way to get this alpha here, okay, the question will be done basically. We'll just have cosine law, and then we'll be done. Now, how can we go get that theta? That's kind of the new question for us right now. So the way we're going to go about this is to realize that the angle between the red, between the red and the blue vector when their tails are together, as you can see in the diagram above, is 100 degrees. So this blue vector here, well, it doesn't have to be just there, right? Vectors float in space, so it can also be right there. So you'll notice now I've set up the red vector and the blue vector's tails together, just as in the diagram above. And as in the diagram above, the angle between these two is 100 degrees. Now, because these blue vectors are parallel, we see a C pattern form. So we have this nice C pattern forming in front of us. And what do we know about a C pattern? We know that the two angles in a C pattern have to add up to 180 degrees. So I'll just get rid of that for right now. And what we're going to do is our theta here, so our 100 plus our theta has to equal 180 degrees. So our theta has to be 80 degrees. And now we have the angle that is between two given side lengths. We need the other side length. This is classic cosine law. So just recreating the triangle really quickly here. We've got 80, 10.7, 12.2, and the magnitude of F3 is what we're looking for. And again, we're going to use the cosine law. So I'd like you to pause the video now and attempt this cosine law on your own, and we'll reconvene in a sec. So hopefully this is what you got. Remember, we're taking the cos of the 80-degree angle, and you get that the magnitude of force 3 is approximately 14.8 newtons. And there really isn't anything to conclude, because the only thing the question asked is find magnitude of F3. We found it. We're done. This concludes section 7.